Knowledge on the spatial distribution of species is vital for any successful conservation plan. However, the geographic species occurrence data that we have are rarely complete or systematic. We tend to use open access species occurrence databases comprised of stochastic reports of sightings, such as the Global Biodiversity Information Facility, or GBIF, but these databases contain pervasive biases, both taxonomical, where people are going to identify what they know and what they readily see, and spatial, where species will be identified where people tend to be, in areas close to roads or close to urban centers. Species distribution models, or SDMs, are commonly used to interpolate from this patchy data to get a more complete picture of a distribution. Doing so by joining available presence only or presence absence species data with geographic predictors in those particular locations, for instance, climatic variables, to predict where else that species is likely to be or not to be. While undeniably useful, however, traditional SDMs still mirror the weaknesses present in the databases on which they are fitted, leading to imperfect detections in the forms of false absences or false presences, thus negatively impacting conservation efforts by misdirecting resources. To remediate this, the novel S2Bach Integrative SDM was developed by our lab. It provides an ameliorated estimation approach by integrating data types, joining the generally more biased open access species occurrence data with rarer, systematically collected species survey plots to fit generalized additive models in order to build both initial distribution predictions and bias adjustment kernels. Using these bias adjustment kernels, we can then predict the nature of bias present in a species occurrence data, how that bias is likely affecting our initial predictions, and we can importantly then adjust our predictions accordingly, leading to an improved predictive power in comparison to traditional models. While this approach was previously highly successful in Panama, for my project I aim to test it by building integrative models for a more widespread European flora, building S2Bach SDMs for all available European plant species, or at least those present in the European Vegetation Archive or in the GBIF datasets that I will use. Through this, my objective is to ultimately provide researchers with an optimized plant biodiversity layer of Europe, representing the most speciose, complete, and fine-scaled vegetation baseline of the continent to date. As severe anthropogenic changes are expected across Europe for the remainder of the 21st century and beyond, a complete continental estimation of plant distributions will be a key tool in answering applied ecological questions to come. Thank you.